Hi everyone. In this video I'm going to talk through Chapter 9, how to work with dates and strings. Let's start with dates and times. Dates and times in our programs can be very handy, especially for things like time date stamp when we're collecting information from our users and storing that information. There's an object that's built into C# called the DateTime object, and every DateTime object includes a year, a month, and a day. You can optionally include the hour and the minute and the second, and you can even include the millisecond if you need that level of precision. You would create a DateTime object much like you would create any other variable. You would name your variable name based upon a particular type, in this case DateTime, then give a variable name based upon our naming convention, and then you could set it equal to any particular date or time that you want to store. And date times have similar methods associated with them to some of our other data types. So you can do things like parse or TryParse to input information into a DateTime variable. We know that dates and times can be recorded in all sorts of different formats based upon where you live and how specific you want to be and how formal you want to be. So the normal way to input information for DateTime would be to specify year and then month and then day and then hour and then minute and then second. And you can see that we can input the 30th of January in 2016, and if we don't specify a time, it'll default to 12 a.m., midnight. If we do specify time, the hours are 0 through 23 for the 24 hours of the day, and of course minutes are 0 through 60, and so are seconds. If you want to enter a date that is formatted the way we would often write it in a Word document or in a letter, you can certainly type dates with slashes or dashes, and Parse and TryParse should be able to interpret those without much issue. So the built-in methods for date times are actually pretty clever. They can take something like 01/30/16 and convert that to a date, or even the abbreviation Jan for January 30, 2016 at 2:15 p.m. and interpret that as a date and time. Here's a list of the date formats that C# will automatically recognize. You can see that you can have leading zeros if you want. You can use slashes or dashes. You can use abbreviated month names, and you can do time in either normal format or what I often think of as military format, where you have 0 through 23 instead of 1 through 12. There are a couple properties associated with date time that are really useful, specifically now and today. They're both very similar. If you use the .today property, it will pick today's date, but it will pick 12 a.m. as the time. If you use the .now property for date time, it will pick exactly this moment in time. So whenever the program is running and that particular line of code is executed, it will pick that particular day and time and store it. Again, very useful for a time date stamp for collecting information from a user. Say if they were placing an order, you'd know exactly when that order was placed. For displaying dates and times, there are lots of methods available to us to make them look the way you want them to look. You can display dates as long dates or short dates, and similarly you can display times as long times or short times. And here's an example of what those might look like. This is similar to when we do our dot to string for other types of formatting, like currency or percentage, but for dates we've got some built-in functionality that's a little bit more robust. When you're working with dates and times, the math can be a little bit tricky. You know, if you've ever tried to do math to add a couple days to a date or subtract a couple hours from a time, that it can get tricky, especially if you're getting to the end of the month or you're getting towards midnight and you're going to wrap around a corner. Fortunately, we have a variety of different properties and methods available to us that make this a little bit easier. And we're going to see some examples of these in some later slides. If you have a particular date that is stored, you can retrieve from it the specific month or hour or year by stating the specific variable name and then a dot for its property and then the specific feature that you're looking for. So dot month or dot hour or dot day of year, which would be anything from 1 to 365. You can also ask how many days are in a particular month. So if you can't remember if there are 30 or 31 days in March or April, you can check. You can also check to see if a particular year is a leap year, and the system will report back the appropriate number or the appropriate true or false as necessary. Another very useful feature is the day of the week property. If you have a specific date that's stored, you can do a dot day of week, and it will tell you whether that day of week is a Monday or a Tuesday or a Thursday or a Saturday. So in this case, you can see a little snippet of code that lets you know that it's the weekend or the weekday based upon the day of week property. In terms of doing math, the methods that are available to us, we can add days, add months, add years. We can add hours or minutes or seconds. We can even add specific time spans, or we can subtract a specific date from another date. So for example, if I add 2 months to the date March 1st, 2016, I get to May 1st, 2016. That means I don't have to think about how many days are in either of those months. If I did try to add 30 days a month or 60 days, that wouldn't actually get us to May 1st. That would get us to April 30th. And so that may not actually be what we want. But by using the .add months method, we do get from one month to another month to another month. Similarly, if you want to add time to a specific date and time, and it takes you around the corner, add minutes or add hours will work properly. So in this case, you can see that in the very last example, we add 12 hours to a specific date and time, and that actually takes us to the next day early in the morning. And the math works out exactly the way that it should. If you're trying to compare dates, the time span is very useful. You can actually look at one date versus another using the date.subtract method, and it will tell you the number of days, hours, minutes, and seconds that those particular items are separated. Time span stores things as a series of ticks, seconds, minutes, hours, and then days, and then you can get those specific separate features from that object as necessary. You can also manipulate dates using mathematical operators or comparison operators. So you can subtract one date from another, or you can ask if one date is larger or smaller than another. And that kind of logic will work. Let's transition from dates and times to manipulating strings. We have been manipulating text all semester, but there are some things that we haven't done yet with strings that we should discuss. First, the way that C# thinks about strings is that every string is actually a one-dimensional array where every character in that string is stored in a specific position. So if we store a string A, B, C, D, E, F, G, the system actually thinks about that as an array with 7 characters positioned 0 through 6. If you ask for the character in position 0, you'll get the letter A. If you ask for the character in position 1, you'll get a B. That means we can do some interesting things with strings. We can use for loops or for each loops to manipulate each individual character that's stored in a string. Both the code at the top of this slide and at the bottom of the slide do the same thing. They insert spaces between each of the characters. The top one uses a traditional for loop, the bottom one uses a for each loop, but the result is the same. There are lots of very powerful methods that you can manipulate strings with. You can check to see if a string starts with a specific value or ends with a specific value. You can check to see where a specific substring is located within a particular string. You can also see the last position of a particular substring. You can insert one or more characters into a specific string. You can add spaces to the beginning or the end of a string. You can remove certain characters from your string. You can replace one part of a string with another. You can grab part of your string and store it someplace else. You can convert your string to all lowercase or all uppercase. And one of my favorites, you can use trim to remove any spaces that are at the beginning or the end of your string. And as an aside, I try to use trim almost every time I'm manipulating user inputted strings, because users sometimes accidentally hit a spacebar before they start typing or after they're done typing, and often we want to get rid of those spaces that are at the beginning or the end of their input. So .trim is a great feature. The last one on this list is split, and it's by far the most powerful, so we'll talk about that in more detail in a later slide. Here you see some examples of starts with or ends with. You also see some examples of getting some indexes of things like spaces, or whether incorporated shows up, or where the last space is located in a string. You'll note for the index 3 example that the result would be a -1, and that's because incorporated doesn't show up in the company name. A -1 means you searched for something and did not find it. Here's some examples of how you can remove specific parts of a string or insert specific parts to a string. Also some examples of how you can replace the lowercase and with a capital A and D. You can see how you could convert names to upper and lowercase. In this case, they take the name Anne and they capitalize its first letter, and then they lowercase the remaining letters and then rebuild the first name. You can also obviously copy from one string to another fairly easily. And unlike other arrays, when you copy a value from one string to another, they are not linked to each other. There's no reference. So if you change the value in one, it doesn't change the value in the other. In many cases, when we're dealing with strings, we want to parse the information that's been given to us and break it out into subcomponents. So for example, what if we had somebody's name, Edward C. Coop? The first thing we might want to do, especially if this is user input, is remove any leading spaces or trailing spaces. The second thing we may want to do is check to see where spaces have occurred in between the different parts of this entry. So the first space is between Edward and C, and the next space is between C and Coop. In this case, once we know the location of the first space, we can store the first name as a substring of the entire string, starting with position 0, all the way out to the first space, so the first 6 characters. Note they have some logic here. If we did not find any spaces in our full name, that would mean that someone's name is something like Cher or Madonna. They don't have any parts to their name, they just have a singular name. So in this case, their first name is their full name. I'm going to encourage you to take this snippet of code and try it out in C# with breakpoint analysis to see how it works. It's quite clever. It takes a long address as a single string, and it parses it by using the vertical character as a delimiter. So the first thing it does is remove any spaces at the beginning or the end of the entry. It also removes any vertical characters at the beginning or the end. And then it works its way through the string, trying to find the various vertical lines. City index is the first vertical line after the street address, and it adds 1 to that. The state index starts where the city index was located and works its way forward and finds the next vertical line. The zip index does something similar. It starts where the state index left off and it finds the next vertical line still. Once you've located those specific positions as index values, you can use substrings and some clever math to separate all of this text out into its components. So you'd have a street address, a city, a state, and a zip. It's hard to explain just looking at the code, but if you walk through this with your own addresses inside your code and using breakpoint analysis, I think it'll make sense to you. An alternative to manual delimiting of a long string is using the split method. Let's go back to our previous example of the name Edward C. Coop. After trimming this name down to get rid of any leading or trailing spaces, let's create a new array called names. Note that it's an array. It has an open and closed square bracket to indicate that it's going to have multiple positions, and it's equal to the full name's .split method. And the .split method has a specific argument that we're sending into it, and in this case it's a space. That's what we're going to use to separate the various components of the longer string. this will automatically build an array that is as large as it needs to be. So if Edward C. Coop's name was Edward C. Coop Jr., we'd have 4 different entries. Edward would be in position 0, C would be in position 1, Coop would be in position 2, and Jr. would be in position 3. In this case, if your name was 16 different words, you'd have 16 different entries in an array with 16 different positions. We can use the split method on our address as well. After removing any leading or trailing spaces in our address and any starting vertical lines, we can use the dot split, where we indicate the vertical line as our delimiter, to separate out our street and city and state and zip code. When split works, it is a great choice for splitting out substrings within a larger string, but sometimes it won't work. Sometimes using a manual method is going to be required, and that's going to be up to you as a programmer to determine which method is appropriate. Other examples might be things like removing hyphens from a phone number or changing a date from dashes to slashes, and I invite you to explore these on your own. We have used Parse and TryParse throughout the semester to take text and convert it to numeric values. There is a more powerful way of using TryParse, and I have given you one example of this, but here are the various number styles and enumeration for decimal values that are available to you in both Parse and TryParse. The best use of TryParse is to take an input from a text box and allow for currency to be input. And I've given you that little snippet of code on this slide, and it was something I provided earlier in the semester as well. And I definitely encourage you to use this version of TryParse if the user is going to be entering currency. It allows them to type $signs and commas the way they normally would, and the TryParse will interpret that input correctly. The remainder of this slide deck discusses StringBuilder objects, which we are not going to use in this class. It also discusses the dot format method, and we're not going to use that either. Dot to string is more than powerful enough for everything we need in this class. So I certainly encourage you to take a look at these slides if you'd like, and feel free to use the various methods and techniques that are listed, but you do not need to know these for any of our assignments or any of our exams as we move through the remainder of the semester. The last thing I'll mention is an invitation to pursue a particular challenge, and that is to write code that would translate an English paragraph into Pig Latin. I will tell you this is a particularly challenging endeavor. I've done this a couple of different times in a couple of different ways, and every time it's taken me quite a few hours to actually get this to work. This is above and beyond anything you are required to do in the class. It won't count for a homework, it won't count for extra credit, and it is certainly not a question I'll be asking on a future exam. But if you're looking for something to do to further explore how coding works and to truly explore how some of the string manipulation might work, this is an excellent exercise. And so for some of you that are looking for a challenge, this might be something that you want to pursue. That's it for this chapter. Thanks for watching. See you next time.